Right, good morning, class. So this very morning we'll be looking at the computer center problem as part of the practice questions that we'll be looking under assignment problem. So here we have computer problem whereby you have 4 programmers and 4 programs that needs to be done. Now the 4 programmers have different estimated computer time in minutes that you can see in each process. So which means that for programmer 1 will be able to actualize program A in 120 minutes, while the same programmer 1 will be able to complete task B in 100 minutes, task C in 80 minutes, and task D in what? In 90 minutes. Now remember that in the last class that we had, when we were talking about assignment problem, we said that the best method of trying to solve assignment problem is we trying as much as possible to use the Hungarian method. And in the Hungarian method is basically reducing method. So it's a principle of reduction. So it deals basically with the principle of what? Of reduction. So it deals basically with the principle of what? Of reduction. So we said with Hungarian method we can at very best be able to get our efficient result if we follow the principle the right way we are expected to what? To follow it. And as we know, assignment problem is all about what? Trying to assign this task to what? To the different experts that we have here at the least possible cost, So here we are trying to look at how best can we assign these programs to the programmers at the least possible computer time that will be taken to do or to get the job done. So the first thing first is always to look at this particular problem and ask ourselves, is it a maximization problem or a minimization problem? Now the fact that we want to reduce the computer time in minutes, that means that is a what? Is a minimization problem. So it's not a what? A maximization problem. Now having that known that is a minimization problem, the next thing you ask yourself is that, is it a balance problem or an imbalanced problem? Now, if you look at the table very well, if you look at the matrix very well, you have a 4x4 matrix, and the fact that you have a 4x4 matrix, it is a square matrix. Now, when it is a square matrix, it means that is what? Is a balance problem. Now, having those two checks being done, that is a balance problem and is a minimization problem, then the next thing you are expected to do is to follow the principles of reduction. And the first thing you do is that you want to try as much as possible to do the row reduction. And how do you do the row reduction? All you need to do is to identify from the initial matrix the least cost on each row. You identify the least cost on each row or the least estimated time, as we have it here in minutes. Look at the least estimated time on each row and you subtract that least estimated time from itself and from every other variables on the what? On the row. So if you look at the first row that is attached to the first programmer, the least cost there is what? Is 80. So if 80 is the least cost, all you need to do is subtract 80 from itself. So 80 from itself will give you what? 0. Then subtract 80 from every other variables that you have there. So here 80 from 120, you have 40 from 100, you have 20 from 90, you have what? You have 10. Same thing goes to what? To the other rows that we have there. So the other row we have what? We have 70. 70 from itself you have 0. From 80 you have 10. You have 20. And you have what? 40. Look at the next row, you have what? 100 as what? As the least computer time in minutes. And 100 from itself you have 0. 100 from 110 you have what? 10. You have 40. And you have what? 20. Then look at the last row. The last row has 80, so we have 280. Any one of it can be selected, and you subtract that 80 from what? From every other variables that we have there. So we have 10, 10, 0, and what? And 0. So here we have the opportunity matrix, opportunity cost or opportunity in time now, since we are looking at estimated computer time matrix that we have now. So this new matrix that we have now is what we are also going to use to do what? To do the column reduction. So we've used the initial matrix for what? For the row reduction. So the next aspect of the principles of reduction is to do the what? Is to do the column reduction. How do we do the column reduction? We just need to identify the least estimated time on each column. So we identify the least estimated time on each column and we use that we subtract that variable from each self and from every other variable. So from the first column we have 10. So 10 is the what? Is the least cost, is the least estimated time. So you subtract 10 from each self, you have what? You have 0. From every other variable you have what? 30, you have 0, and you have what? And you have 0. Then go to the next column. The next column, which is under task B, we have 10 as the what? As the least estimated time. So you subtract 10 from itself, you have what? 0, you have 30, you have 10, and you have what? You have 10. If you look at the next one, it is what? 0. So you subtract 0 from itself, you have 0, and then from every other variable, you have them standing the way they are. So when you go to the next column, you also have 0, so which means that we just have to repeat the variables the way they are there. Now, having done this, here we have been able to do what? We have been able to follow the two basic principles of what? Reduction. The row reduction and the what? And the column reduction. The next thing we are supposed to do is we are supposed to look at how best can we what? Allocate these variables to the right set of what? To the right set of programmers. So we have programs here, 4 programs that needs to be allocated or assigned to what? 4 different what? Programmers. So the first thing I will advise us to do is to look at the numbers of zeros that we have on each row. So on each row we have 1 0 here, we have 2, we have 2, then we have what? 4 0 here. If you look at column wise, we have what? 3 0 here, we have what? 1 0 here, we have 2, then we have what? 3 0 here. Now, why are we doing this? The reason why we are doing this is for us to be able to ask ourselves that if we can draw lines on these zeros to cover these zeros, if these lines can, if we can have at least 4 lines to cover these zeros that we have here, ultimately, then we should be able to do our allocation as easy as what? As possible. Now we follow what? Follow the principle of first cancelling the what? The rows that have the what? The highest 0. So if you have to cancel the row that has the highest 0, you cross out this row because it's having the what? The highest 0. Then the next aspect of it is we cross out this because it's having the what? The highest 0. Then the next one is what? Is D, column D, that is having what? The highest 0. If you notice, the only 0 that we have here is now under what? Row 1 or what? Column C. So anyhow, you can put it anyhow. So we can do it this way. Now, the fact that we have 4 zeros, 4 lines, that is equals to the number of rows that we have, number of rows, as well as the number of columns. Since our number of rows and columns are 4 and we have 4 lines, that means that we can ultimately do what? Do our allocation. We can ultimately do our allocation without any issue whatsoever. Without any issue whatsoever. So what do we need to do? Since there are 4 lines that tallies with the number of rows and columns, all we need to do is to ask ourselves, for programmer 1, where do we have the zeros? We have the zeros at what? At task C. For programmer 2, where do we have the zeros? We have the zeros at what? Task A and what? Task D. For programmer 3, where do we have the zeros? We have the zeros at what? As A and what? And D. Then for programmer 4, where do we have the zeros? We have the zeros at what? A, B, C, and what? And D. We have the zeros at what? A, B, C, and what? And D. Now, having said this, all we now need to do is to ask ourselves, because the opportunity cost of we allocating programmer 1 to C, to task C, is just what? Is 0. So which means that it is best for us to allocate that particular job to what? To that particular program. Then the next thing we have to look at is that, so the moment we have done this, it means that every other place that program C is showing, we have to do what? We have to cancel it. So because the allocation has been done here, so it means that it has to be cancelled here. Now if you look at this task and expert that we have here, if you notice, we are only having B under what? Under program 4, under programmer 4. So which means we have to allocate B to what? Programmer 4. Why every other task, every other programs that are there are being what? Are being cancelled. Now, the moment we have been able to do that, what we now have here is that we have a scenario whereby programmer 2 and programmer 3 are seen as experts in both task A and D. Task A and D. So now that we have a scenario whereby they are seen as experts in both jobs, so it is either we go this route, allocate 2 to what? To A, while we cancel A here, then 3 takes what? Takes D. Or we go the other way around by allocating 2 to what? Allocating 2 to D, while D is being cancelled here, then 3 takes the other what? So which means that in this problem that we have, this computer center problem, we are going to have 2 possible answers. That 2 possible answers, as we are going to have it here, so we are having multiple answers whereby we have 1 to what? To C, 2 to what? To A, 3 to what? To D, then 4 to what? To B. Or we have 1 to what? To C, 2 to what? To D, 3 to what? To A, then 4 to what? To B. So these are 2 possible answers that it is expected for us to what? To have. So what are we expected to do now? So what we are expected to do now is that, since we already know that, okay, the best way to allocate this job to the programmers is what we have here. The next thing is we have to attach is what? We attach the estimated time minutes. So what is the estimated time minutes here? We have 80. The time minutes at 2 to A is also what? 80. The time minute at 2 to D is the point of intersection D3, which is what? 100. And the time minutes for 4 to B is what? Is 90. So that is being summed up, and we have what? 350 minutes. Then we have 350 minutes. We have 350 minutes. So if you look at the other way around too, so that here we have 80, 2 to D is what? 70, 3 to A is what? 110, then 4 to B is what? Is 90. When you sum it up, you also have what? 350 minutes. So what it means is that we have 2 possible answers for this particular program. But in cases whereby you have 2 possible answers, but one particular one is giving you 350 and the other one is giving you 310, you have to select the one that gives you the what? The lesser. So this is what we'll be looking at for today. Then the next time we also look at another practice question. Thank you very much.